So finding the equation of the tangent line is going to take you all the way back to grade 10. Do you remember these things you learned in grade 10? Y equals mx plus b. Ringing a bell? Where m is your what? Slope. And slope is your what over the what? Rise over run. And do you remember what the b part was? It is the what of the graph? Y-intercept. You learned this form, rise, x minus x1, run, y minus y1, where obviously rise, the run, was the slope stuff. And then those numbers there were for any point in your graph, not your y-intercept necessarily. It could be any point. And then why do you think I'm going to write opposite? Because the equation has subtracting, so you would write the opposite. Okay, so let's see how this works.
What do you mean by opposite?
So if my coordinate it has an x value of 2, my equation will say x minus 2. If my coordinate has an x value of negative 2, my equation will say plus 2. Okay. Everybody knows what a tangent line is or whatever, touching one spot. If the slope of this is, let's say, 2/3, do you know what the slope of a perpendicular line would be? Well, this is going uphill and this is going downhill. So one thing I know is that it would have an opposite sign. And then I would flip. Do you remember that rule from grade 10? Perpendicular, negative reciprocal. Okay, now you know how to do it. So let's try some examples. Find the equation of the tangent line. So first of all, how do you get slopes of tangent lines? How do you get a slope? You do a what kind of process? Derive. So I need the derivative of this. So 6x minus 2. So what is the slope when x is at this point? So when there's a 2. So 6 times 2 minus 2 is 10, right? So our slope is 10, or 10 over 1 if you want to write it as like a rise over run situation. Okay, what form do you want to go with? Would you go with slope-intercept form? And the reason I would use slope-intercept form is because I knew the slope and the y-intercept. Or do you want to do slope-point form because you know slope and a point? Slope and a point. So 10 brackets, 1 brackets. There was an x here, there was a y here. And then I have to fill in the coordinate of the point with opposite. So if this is 2, minus 2, if this is 8, this will be minus 8. This, the point. That guy right there. See it? Okay. Write the equation of the normal line, which is the perpendicular line. So what did I say about perpendicular slope? If the slope over here was 10 over 1, what's the perpendicular slope? Negative 1/10. So that's all I do, is I'm change the slope. Negative 1/10 is now the slope. Okay, here we go again. Same thing. Find the equations of the tangent and the normal line. So first of all, I want to figure out the slope. So I derive. So derive. And I'm trying to get all this tangent stuff specifically at 3. So now figure out your number. What is the slope? So here's something I know. I know the tangent line has a slope of 15, or 15 over 1. And the normal perpendicular line would be negative 1/15. So what should we do here? Should we use y-intercept, because we know that, or should we use the point one? Which one do you want to go with? Probably the point one again, except for I don't really know the point. Could you figure out the point? 3 comma, can you figure out the point? Where are you plugging it into? Kelly? I'm in teaching for 2 minutes time. Yep. Where are you plugging that in? To the original or to the slope? Original.
OG.
The OG. 27 minus 18, right? Is that 9? Okay, so here's your answer. There's my point plugged in, and you can see how I wrote the tangent equation, and then here's the perpendicular normal equation. Okay, last example, and then we're done with the unit. So figure out the equation of the tangent line when it's parallel to this other line somewhere. Okay, so here's what we're going to start with again. Slope equation. So the derivative is 4x minus 5. Okay, here's some wording. I'm gonna figure out, I don't have x values now this time, when are we gonna be parallel to this other line? What do you know if you're parallel to something? What are you going to think about their slopes of something when you're parallel to it? Slopes have to be the same. So what's the slope of this line? Because I want to have the same. What's the slope of that equation? 7, right? 7x, that's the m. Okay, so I would like to have a slope of 7. So what am I going to do? Where should I put the 7? In place of the slope. So what am I doing? I'm trying to figure out what x position am I at a slope of 7? Okay, figure that out. Add, divide. Okay, so here's what I figured out. When x is 3, my tangent line has that 7 slope. Can you get me a coordinate again? 3 comma, and where am I plugging that into? Original. So that's the plug-in. 2 times 9, 18, minus 15. Is that just 3? Okay, so then you can see me filling into the equation. 7/1 is the slope, coordinate.